So let's take a look at the rest of task 1.4. So there is the f of x. I'm going to find the inverse. I'm going to use the equation. And what I'm going to do is flip the x in the f of x. And when I do that, I get x over here. And then I get the inverse of f on the inside. That's the effect of flipping it. And then I just got to solve for f inverse. And I end up with 3x minus 5. And then I check it. Right, I do the composite function. Right, I take the inverse and I plug it in to f of x. So I plug it in right there. Right, and if I do that, I should get x. And you can follow the math, and I do. And this is what it looks like on Desmos when I plot it. So there's f of x. I've called the inverse g of x. I've also put the line x equals y, so you see symmetry about that line. And so that's how we would know that these are inverses of each other. So here's the function f of x is equal to x minus 3 squared. So by equation, right, I'm going to put the x, right, where the f of x was. And then where x was, I'm going to put inverse of x. And so now to find, I just need to solve this equation for f inverse of x. So I've got to deal with the squared out there. So I'm going to square root each side. And that's going to remove the exponent. And then I just have to do simple math to find the inverse. I check it just to make sure I've got the right answer. So I take the inverse function and I plug it into the original function. So I'm going to take that quantity right there and I'm going to plug it in for x right there. And so that's what I'm doing math-wise. Right, the plus 3 and the minus 3, right, those cancel. And so I've got the square root squared, and that equals x. So we'll take a look at it on Desmos. So there's f of x, x minus 3 squared. G of x is square root x plus 3. And so we've got a little bit of a, we're going to have to limit the domain here to make this invertible. And so it would be from here positive. So from 3 to infinity would be the domain of f of x. And that would give us this function that would be invertible right here. Because if we inverted this whole thing, right, we would end up with something that was not a function. It would fail the vertical line test. All right, we got one more. So it was f of x is equal to 4 minus square root of x. So I'm going to do it by the equation. And so I'm going to put x. All right, I'm going to flip x and f of x. And when you do that, you get the inverse. You have to put the inverse over there. And so now it just becomes math to solve for it. So subtract 4. There's minus 4. Multiply by negative 1. Right, that negative right there. I'm going to multiply by negative 1 and then square it. So there's the equation. And let's go take a look at Desmos. And so here it is on Desmos. And so we've got this function right here. That's the 4 minus x squared. And then here's the 4 minus square root of x. And so we would see where the restricted domain would be this way to be able to make this work. And so we would have a picture. So you see the symmetry right here of this piece and that piece right there. And so we've got the inverted function. So the last topic, and we're going to do this in 1.3 as well, but it's logs and exponents. Those are inverses of each other. So we're going to learn a little bit more about it, but if that's f of x, where it's a base to an x power, so there's our independent variable. And so the inversion of f of x would be the log. So to get an exponent, to undo an exponent, you have to take a log, and we have to be aware of the base of that log. So there can be, there's a range of numbers that can show up down there. So here would be our example. So f of x is 2x minus 10. And you kind of see where we end up stuck here, because we can move the 10 to the other side. But at this point, we can't do anything that we've normally done, except we're going to take the log of both sides. And so we end up by taking the log of this side, we get the exponent to come down. So that's what the logarithm does. And so there is the inverted, or the inverse of the function. So the inverse of 2x minus 10 is equal to the log base 2 of x plus 10. And so if we just talk through that, right, x plus 10, right, there's in the original function it was minus 10 was the last thing done, and then the log base 2, and the first thing done to x was to do base 2 with the exponent x. So it's got that same form of doing the operations, the inversion operations backwards. And then this is what it looks like on Desmos. There's f of x. All right, there's g of x log base 2. So to get the base, you have to get the dash line, like the small version of it, the small line. That'll give you a subscript, is what that is called. And then there's the argument x plus 10. So that's that blue line right there. The red line is 2 to the x minus 10. And so you see the symmetry about y equals x.